Okay, so we now have our vehicle, and again, it's cruising around and stuff, and it looks okay. I can't really see the side of it unless I do a sharp turn, so I'm going to go ahead and first put, well, we'll do turning first. We're going to do wheel turning, so I won't move my camera yet. So we'll start by handling the wheel turning. So right now, the wheels remain straight. Obviously, in traditional motorized vehicles, to turn, your front two wheels turn left and right, following the direction you have facing the which way you turn the steering wheel. Let's go ahead and create that functionality now. We're going to do that by making it an extension of the turning movement. So in our turning movement, we have our torque set up here so that, again, we turn when we're pressing A, it multiplies a -1 with our turn multiplier, and we're pressing D, it multiplies, +1 with our turn multiplier to have us turn both directions. With an axis value, this is constantly sending out a signal, so if I'm not pressing down on any button, then this is outputting a value of 0. So what I'm going to do is I'm going to go ahead, and what we really want to do, if we just kind of look at it in here, is whenever we turn the wheel, we want to rotate the wheel like this. Okay? Now what I have selected right now is actually the wheel mesh. The reason we don't, we could theoretically rotate it like this, but the issue is here in a second, we're going to actually be rotating the wheel to spin it. And if you rotate this and then try to rotate that, you can get some weirdness. So instead of rotating the wheel itself, we're going to go ahead and rotate its parent. So instead, I'll grab the FD wheel parent, and to rotate it, we're going to use this to go back and forth. Okay. Okay. So I'm going to go ahead and hop into my event graph. I'm going to extend this out, and we're just going to go ahead and say set relative rotation. And I'm going to set the relative rotation on my FD axle, and not just my FD axle, but also my FP axle. And I just typed in axle. I don't want to do axle, I'm sorry. I want to do FD wheel parent and FP wheel parent. It's the wheel parents we want, not the axles. The axles are line traces, so that you don't want to, it wouldn't hurt anything for those to be rotated, but it also wouldn't do anything. So I'm going to go ahead and plug this in here. Okay, I got my wheel parents. Let's go ahead and click on here, click my wheel parents. Okay. And I want to rotate this. And right now I'm looking to see what value is changing over here on the right side. Right over here. I can see that when I rotate this, what's actually changing is my Z value. So that's what I wanted to know. I also need to kind of make a decision about how much rotation I want. Am I going to be, when I turn, do I want it to go 180 degrees? Probably not. Could you get by with 40, 45 or 50? Maybe you could, but it's probably a little bit extreme. I'm going to go a little bit softer, and I'm going to say probably somewhere between 20 and 30 degrees. Maybe I'll just do 25 just to be safe. Okay. So I'm going to go into the event graph, and I'm going to expand this area here, split structure pin, and the value again that was changing, there was a Z value. So all I'm going to do is multiply this float value with 25. And again, you guys can customize this a little bit. If 25 feels too extreme for you, then you can go less. If you feel like you really want the wheels to really crank when you hit the left and right, you can make it larger. This is being multiplied with a positive and -1 if it's being turning, so it will do both, should do both sides, both directions. When I compile and save, and now we're going forward, as we turn, our wheels at least turn to follow. And again, honestly, even 25, when I'm looking at it like this, feels a little weird. I'd have to see how it looks with the final body and everything. And truthfully, it's something that I probably will have to adjust later just to match what feels good. Okay? But it still feels more natural just to see those wheels turned when I'm turning. Normally, the body's going to block a lot of the wheel turn as we're doing it, so it's going to look a little bit smoother. There are steps we could take to have the wheels kind of turn more slowly, but it would add a lot of code and probably more than we want to cover for this particular game. Okay, sweet. So we've achieved our first thing we wanted to do, which was basically allowing our wheels to turn left and right. The second thing we're going to go ahead and do is we're going to go ahead and create a speedometer, and we're going to do that next because we're going to rotate our spin our wheels based on how fast we're traveling. So that's why we're going to start with our speedometer first. Any questions at this point before I go on? Okay. So I'm going to go ahead and we're going to go ahead and create a speedometer. I'm going to start by creating a custom event. And I'll just go ahead and call it speedometer. Or I can't even read that. No. Speedometer. Okay, and I'm going to go ahead and call this I'm going to call this on event tick, but I will say, right, as I do it, I'm cringing a little bit. Because truthfully, the speedometer probably doesn't need to be updated every frame. Speedometer is probably something that could be updated every half second, or maybe a third of a second or a quarter, and it would probably still be fine. This is one example of something I'm putting on event tick right now that could probably be done less often. So when you start getting to a point where you want to optimize your game, really ask yourself, is this a question I need to ask every frame? Because again, something like speedometer could probably be updated less often and would still do the job. Okay, so I'm going to run speedometer. And I'm going to go ahead, and the first thing I'm going to do is right-click. Well, I'm going to grab my static mesh from the components area, and with that, I'm going to get velocity. I'm going to get the physics velocity, or sorry, I'm going to get component velocity. And what you're going to see is that it's going to return the velocity of this. But if we print this now, let's just go ahead and take a look at what it looks like. We can see that it's coming out in a vector value, which isn't super useful to us when we're trying to determine our speed. It's going to tell us in X, Y, and Z how fast we're moving, basically. Obviously, when we're moving up hills, we're obviously moving somewhat in a Z value. Most of the time, we're just moving in X and Y, which is, kind of the direction we're moving. We're going to go ahead and make this slightly more useful to us by getting the length of this. And so we're going to get the vector length. And plug that in. And now we're getting a single value, which is a lot more useful than the other. Does anybody have any idea what we're actually seeing here? We're seeing things in 1600, 1500. Does anybody have an idea what that unit of measurement is? I can tell you right now, it's not miles per hour yet. Anybody have any guesses? It is centimeters. So that was a great guess. It's not feet. Corey, it is actually, Nicholas was correct. It is centimeters, and it's centimeters per second. That's the default value that comes out of that get velocity. It returns it in centimeters per second. Everything in Unreal Engine 4 by default is going to work relative to centimeters. But yeah, I kind of wish it was feet for me personally because I understand that better, but that's just an American thing. Okay, so we need to basically do a conversion here. And so what we're going to do is, right now I'm getting something in centimeters per second, but I want to convert it into miles per hour, at least if it's a number we're kind of used to. Again, you wouldn't have to do that, but even obviously in England, they don't use, when you're looking at your speed gauge, they don't look at centimeters per second or centimeters per hour, they look at kilometers per hour. So it's still, you probably need to change this either way. So what we're going to do is, the first thing we're going to do is this is centimeters per second, so we're going to convert it to hours instead of seconds. So we're going to take this value times float times float, and we're going to go ahead and take it times 3,600. There are 3,600 seconds in an hour, and so that's how you get that. So basically now this has become centimeters per hour, that amount. And then the conversion, if you want to convert centimeters per hour to miles per hour, the you have to basically divide it by, I've got the number here, I'm going to have to look at it, 160934. Okay. And that should give you reasonably accurate miles per hour. I mean, I'm not saying it's perfect, but it's close enough. Okay. And so this is now returning your miles per hour. When you're falling, it actually does still register that, so you know your speed is actually even your falling speed. So right now I'm going about 30 miles an hour, which makes sense. Yeah, when you're driving around the highway, you're driving 70 miles an hour, 75, 80, but that's a perfectly flat surface. If you're driving out on any sort of rough terrain like what we're seeing here, 70 miles an hour would be an insane amount of speed. So recognize that you will need to kind of, at the end of the day, the most important thing is that your game is fun. If the way your game is structured, you have to drive 100 miles an hour to make it fun, that's great. But if you're cruising over the dunes at 25 miles an hour feels good, that's fine too. We can always tweak those values later to make it seem like we're going faster. Maybe I'm actually, in the size of the world and the size of my vehicle and everything, maybe I'm only going 30 miles an hour. But I can always fib that a little bit and double it and say, oh, I'm going 60, even if I'm not really going that fast, just to make it more exciting. Ironically, I watched the movie Speed last night, and that's kind of what I was thinking about as I think about it now. In that movie, supposedly they never dropped below 50, but half the stuff they were doing, there's no way you could do it above 50. It'd be horrible. So I guarantee you most of the time in that movie, they were probably only driving 20 or 30 miles an hour at most. Anyways, so we now have a speedometer, and right now we're just displaying it like this. You know, if we reduce how long it stays on screen, maybe if we split the duration to 0.2 seconds or so, maybe we won't get that long string. Yeah, that's not quite as long. I could go a little lower. 0.1. There you go. And you can still kind of see it, but it's a little bit less. If it's bothering you that's going across the whole, reduce how long it stays on, it should help with that a little bit. So we now have a speedometer. Let's go ahead and put a comment code on that. And if I misspell any of this, I apologize. I think that's right, though. So we've got that all worked out. And now that we have our speedometer ready to do our final thing we're going to do for this class period, which is going to be getting our wheels spinning. So our wheels, there's a couple different ways we can approach this. We could have our wheels only spin based on when we're holding down the W key, so we could actually do it off of this forward movement area, just like how we did here on the turning. But it might look a little bit, there's times where we're not actually pressing down on the steering wheel that we could actually be rolling, for example. So if I'm going down a hill and I'm moving, I still want my wheels to turn. So I'm going to do it actually as a separate event tick as opposed to doing it on here. I'll go ahead and create a new custom event. I'm just going to go ahead and call this spin wheels. Whoops. Caps lock. Okay, so we got spin wheels. And let's look again at kind of what we're doing. A lot of times I just pop over here to the viewport and I'm just trying to figure out what I'm doing. So I'll select my front wheel here. And what I'm looking to do here is actually rotate this value here. And the value that's actually changing here is Y. So we use Z a lot, but actually what I'm doing here is actually a Y change. So I need to rotate on Y. And in this case, what we normally do is we do sets and adds and that sort of thing. The issue is, the thing you have to consider with these is as you rotate, if you look, it goes negative, 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 and then at a certain point it's going to flip over on itself and start going back down. And so it's the whole 0 to 180 degree type of thing that gets really confusing. So instead of doing sets and adding and taking into account the flip over position, we're going to go ahead and use what's called add local rotation. And we'll go ahead and start with our, we'll just pick one of the meshes. So I'm going to go ahead and pick FD wheel mesh. Oops, not the parent. Well, I could change it out. So I'm going to add local rotation. I'm going to go ahead and split this structure. And for the targets, I need all of my wheels to spin. So I'm going to go up here to the upper left-hand corner. I'm going to grab each one of these. I'm just holding control. Actually, I don't think I can do more than one at once. Anyways, let's try it. Oh, no, it does let me do more than once. Okay. And so I have all 4 of these. I'm just going to go ahead and get these in here. And we'll just plug all of them into this add local rotation. Okay. And we'll go ahead and let's just try a value. I'm going to go ahead and try, well, I want it to spin faster when I'm going faster. So I'm going to go ahead and pull in I need to pull in my miles per hour speed. Now I could actually pull off of here and just kind of connect it, but I think it's going to be a little bit easier if I create a variable for this. So I'm going to move this over. I'm just going to promote this to a variable. And one thing I didn't do on here that, just for simplicity's sake, that might be easier if I do now is, it should be fine. We'll just try it. We'll see how this goes. Before, I've actually rounded this off, so I basically turned this into an integer, so it kind of rounded off that number, but I think it'll be fine like this. Let's go ahead, and we're going to go ahead and call this miles per hour speed. And I can start putting this in here. Okay. So the thing I've really done is give myself a variable to access. So I have that variable now. I'm going to take that miles per hour speed, drag it in, say get miles per hour speed. I'm just going to go ahead and multiply that, float times float, with another value. Okay. And that I'm going to go ahead and plug that into the y value because that's what we said we wanted to spin. And I'm going to go ahead and try a value. Let's just go ahead and start with a value of, let's start with 10. See what happens. Okay. First of all, I'm having trouble kind of even seeing what's happening. So I'm going to go ahead and switch to my viewport and grab my spring arm and rotate to the side so I can kind of see what I'm looking at. Okay. And right now, nothing is happening. So I've obviously missed some step here. I'm doing something wrong. And I think about it, I already know what it is, pretty sure. But anybody have a guess? Nothing is happening right now. Anybody have a guess what's happening? Why that is? If you've made a change and you feel like you should be seeing something, but you're seeing absolutely nothing, there's no effect at all, the first thing you should always ask yourself is my function even being called? Is this actually even happening? And this is spin wheels, but it's not actually happening because I didn't put it on my event tick. So I'm going to go ahead and drag this over and say spin wheels. Okay. Let's go with that. We'll test it out again. Okay. Oh. That's a little crazy looking. That's maybe not what we want. Maybe it's our value. Maybe our value's a little bit off. Let's try something else. Let's try a little bit lower value. Let's try 1. Okay. I mean, it looks a little bit, whoa, it looks a little bit less crazy. But maybe it's still a little bit faster than I want. And I also don't know if you could tell, but it's also going the wrong way. So to make it go the right way, we're going to go ahead and take it times a negative value. And we're going to go ahead, and it still seems a little fast, so I'm going to go ahead and try a lower value. Let's try a value of like, I don't know, let's try 0.4. Okay. And now our wheels are spinning. And we're much, you know, on the higher end, it looks like maybe they're still spinning up maybe a little bit too fast, but it's not bad. And again, keep in mind, you're not going to view it this way when you're actually viewing it. You won't be viewing it quite from the side like this. But it's not too bad. You know what I mean? And it definitely starting to feel much more like a car as I'm kind of cruising around in here and seeing it. Okay. And so now I have our wheels spinning. One thing I should point out, right now we still have those traces. We're seeing those red lines below there. Now might be a good time to also, kind of hide those. So that spin wheel seems to be working well. To hide those line traces, remember we can go in here and all we need to do is turn off this draw debug frame. I'll set that to none. 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 So again, it's all about getting closer and closer to that end experience we want our players to feel. So those red lines can be kind of distracting. So you can kind of see, okay. Okay. And keep in mind, there's still things you're going to be able to customize. If the suspension still feels kind of floaty, you can still increase the linear dampening, and it will not be quite as bouncy and stuff. So it's definitely something you can do. I'm going to go ahead and just so I can kind of see it real quick from that back viewport. I mean, from kind of a normal back view, I feel like that's going to be where I'm going to normally see it from. Look like this. And again, we're starting to get a better feel for kind of what this game is going to look like as we kind of continue on. And again, you guys need to take your time too and design your experience based on your terrain. Most of the time, this is feeling pretty good. Every once in a while, I hit some of these really weird jumps where it just kind of gets kind of crazy. But there's some fine tuning I could do with my certain elements to kind of make this a little bit better. So, sweet. Okay, so that was the main thing I wanted to cover today. I still got to make all my rounds and kind of check all your guys' milestones. So I don't. That's probably all I'm going to cover today. Are there any questions for me? Anything I can help you with? I'm going to go ahead and stop the video here.